Okay, so in Moodle, I have developed, or we, as a math faculty, we developed a schedule for workbooks completion. So if you click on this link, it will take you to what problems I would like for you to do in each section. You may, like I said, make sure you check your answers as you go. And then after you finish these problems from every week, week 2, week 3, and so forth, I will let you know what problems and pages to upload in Moodle because this is where you'll be ready to test. Now for DMA 40, you won't be able to test until April the 8th. That'll be the first day we're officially rolled in DMA 40. So that will be your first day that you can test. But other than that, you could just continue to work, and then again, we'll work on seeing what we can do to try to get DMA 50 in before the end of the semester. So we're still working things out. Hopefully, we can get that done, and I'll let you know as soon as possible. Okay, so for looking at the majority of everybody that's working on DMA 40, that you are pretty much done with section 1, but I still wanted to go over a few sections from that section. And while this is pulling up, I'm going to pull up my calculator. So I wanted to go over number 8 and number 10 and to view an example. So like I said, this section here is basically what we're doing is substituting. So if I'm telling you y is equal to 4 and z is equal to 5, this is where we replace the y with 4. And because they're side by side, we all know side by side means multiplication. And then we replace the z with 5 here. So because these in parentheses, remember what we talked about in DMA 10 with please excuse my dear Aunt Sally, please meaning the parentheses, and then e meaning the exponent. So we're going to do what's inside the parentheses first by multiplying the 7 to 4 together and the 5 and 5 together, then subtract them, and then once we're completed everything inside of the parentheses, then we'll raise it to the third power. So 28 minus the 25, and that gives us 3 to the third, and then that's going to just be 27. So 3 times 3 times 3 gives us 27. Number 10 is also one of the ones. Now this one here, since everybody probably completed, what you probably did was you substituted t for 12, 13, 14, and 15 by putting in your calculator probably like this. So we do 16. Actually, I'm going to do let's do the view example 1. Okay, they use 16 too, but they're going to use 21. So you probably did 16 and then in parentheses, or you probably hit times 21 and then you raised it to and you squared it. And you got the answer to be 7,056. So this is the answer for the first one, 7,056. But you can also, and this will be helpful when we get into DMA 50, if you want to use the y equals feature, it will probably, you can get the answers a lot quicker doing that way. So you put the same equation in 16. Instead of t, we have to use x. And then you square. And then if you hit second table, you can either scroll down to 21 or we can hit second and then window and we can ask to start at 21. So instead of -3, I'm actually going to start it at 21, hit second and then graph. And then you see 21 is the same thing as saying 7,056. And then once, what are the other ones? I think is going to be, they want us to figure out 22, 23, and 24. So it's all kind of listed here. 22 is equal to this, 23, 24. So it kind of keeps us from putting in our calculator every single one and getting our answer by using the y equals feature and second table to bring out that table. So it's just a quicker way to do it. There's no right or wrong, but it just, like I said, it can make things a little bit quicker to do it that way. So those are the two ones I wanted to show you in section 1. So let's move on to section 2 now. And I want to kind of go over a few of the terminology in section 1. So the first word that you would need to know is about commutative property. If you had to make a one definition word that kind of sums up what commutative property is, I would say just write down the word switch. Because basically what we're doing with the problem is if I have n times k, we're just switching it, k times n. We can see this a lot with multiplication and addition. When you switch them, the answer will still be the same. So that's a one word definition for commutative. It's just pretty much where all we're doing is switching. So if we move to the next word, which is associative, a one word definition for that one you can write down to be regrouping. So an example of regrouping is if I have A plus C in parentheses, I'm sorry, A plus B plus C, and A and B is in parentheses, all I'm going to do is just take the parentheses and regroup it to B and C. So kind of just move it to the back. So it's in the front, we just move to the back. So regrouping is a good definition that I use to explain what associative property means. The next word is going to be distribute. One word definition for distribute will be sharing. We're going to be sharing by multiplying. So you would take this -5 inside to the 2, to the -7, and to the understood 1 that's actually in front of this n, and multiply them together. And then that will provide the answer for this particular problem. And this is what distributing means. So we're just sharing this -5 to every part inside of what is side by side with by multiplying. So I did want to do one example or explain one example, and this is going to be number 7. So we're going to ask, this problem here is actually using this distributed problem. So this one here, we're actually going to work backwards. If you look at this problem, if I have something multiplied on the outside with A plus B in parentheses, A plus C in parentheses, all I'm doing again, distributed properly means I'm just distributing it to here and distributing it to here, so making it A plus AB. This actually should be an equal sign, but A plus AB plus AC. So if I want to go backwards, if I have 52A plus 52B, if I actually take it out and put it back on the outside, do you agree that both of these equal each other? So if I distribute this inside, it's going to look like this. So if I take the 52 out of both of these parts, it's going to look like this. So they pretty much want you to go work backwards as far as the distributed property for this particular problem. That's pretty much all in section 2. So we're going to move to section 3 now. In section 3, it's all about collecting like terms. So collecting like terms, what we're looking for in the problem is anything that has similar variables is what we're going to do combine together, or if they're just numbers or coefficients, then we're going to combine those together. So a good example, looking at this one. So for this particular one, I have 3.6x, and then over here I have a x over here. And what number is understood to be in front of this? It'll be a 1. And also too, just a quick note when looking at when you're viewing my videos, if you want to actually do a lot of pausing, so you can actually write notes, take notes, and actually work the problem out before I actually provide the answer or you see the answer, it's a great way to learn a lot of these problems. So do a lot of pausing and resuming, pausing and resuming to while you're, if you want to look at the problems in when I post this in Moodle. So back to the problem, 3.6x and x, these two are alike, And because this one here, the second one has a plus sign, I'm actually going to take both of these and add them together. So there's again an understood 1 to be in front. So you put in your calculator 3.6 plus 1, and that will provide us what the answer is x. Here is a number, and here's another number. So when you're actually writing this problem down, it'd probably be good if you actually use colored pencils or shapes. So if you want to put all the x's in boxes, and then maybe put the regular numbers in circles. That way you know which two you actually trying to combine together. So for this one here, I'm actually taking negative 1.2 and subtracting it by 2.9. Always do what the second part says. If you're ever wondering, should I add them or subtract them? Whatever the second part in or the last part in the like terms is, this is what you're actually going to be doing. So in your calculator is negative 1.2 minus 2.9, and then we add those two together and we get this at the end. So when we add it, we get 4.6x. So when we add this one and the one together, and then we subtract these two, we get this together. Now here, we're not going to move any further. A lot of students want to go ahead and say 4.6 minus 4.1. And we don't want to do that because, again, what are we trying to learn in this section? Combining like terms. So like terms meaning this have to have an x beside it before we can subtract it. So this has an x, this does not, this is going to be actually our final answer. You don't do anything else to the problem. So let me jump to number 6, example. So here we're going to use what we learned in section 2, we're distributing property. And once you distribute, you are allowed to remove the parentheses. So as soon as you distribute, you can remove the parentheses from the problem. So from here, because the negative 3 is side by side to what's inside the parentheses, I'm going to take the negative 3 times the 7 and take the negative 3 times the negative 4. Because again, I notice you think this is a subtracting sign, but once we start distributing, you got to kind of separate them. And now this becomes a positive 7 and a negative 4. One thing you need to also make a note of, that a lot of students want to take this negative 3 and multiply it to the 7, to the negative 4, and all over here to the 3n. This is what you do not want to do, and it's illegal in math. You cannot jump over. Whatever this is side by side in parentheses is the only thing you multiply by. Don't come over here and multiply it to the 3n. So once we do the multiplication, negative 3 times 7 gives us negative 21n. Negative 3 times a negative 4 gives two negatives, make a what? A positive 12 plus 3n. So looking at this one here, are we done? Is this the final answer? This one will not be, because we still have to simplify this expression. Simplifying the expression also means collect like terms. So if you want to put those two together, if you are collecting like terms, simplifying the expression means both the same thing. So then I'll notice here I can put a box around the n here and a box around this 3n here, because these are the only two that are alike. So these are the only ones I'm actually going to add together, and I'm adding because of the plus sign in the second part. So negative 21n plus 3n, and when we add those two together, it gives us negative 18n, and then I'll leave the 12 alone. Because again, just a reminder, the 12 does not have a letter, a variable, n, so we don't have to add these together. This will be actually our final answer, and this will be considered to be a simplified expression. There's nothing else you can do to this problem. Let's look at just one more example from this section. So here I have 5k minus, in parentheses, 3k minus 10. So this one here is a tricky part, because in the previous problem we had a number to distribute inside, but here there is no number. But there's always an understood number, especially when you have a subtraction sign. If you don't ever see a number, it's always going to be 1. So actually they're going to be distributing a negative 1 inside this parentheses. Basically with this one, we're just going to be changing the signs inside of here and here. So if we take this negative 1 inside, so this negative 1 times this positive 3 makes a minus 3k. This negative times this negative 10, these two negatives create this positive, and we have the 10. So here's the two negatives that makes the positive, and then this negative here tacks on here. So this one here, once we distribute in, becomes a minus, becomes a plus. Now looking at this problem here, we have 5k minus 3k, which are like terms. So you can put a triangle around it or a circle, whatever you want to do, because we have these two being alike. These can be combined, giving us 2k. And then the 10 gets tacked on because there's nothing alike with this 10. So our final answer here will be 2k plus 10. So that takes care of sections 1 through 3. This again, it went kind of fast, but like I said, you can review this video anytime you want to, multiple times on your own time when you have more time. Now, section 4, section 5, and section 6 all kind of run together. So 4, 5, and 6 all kind of run together. So I'm going to actually do all this in one swoop, and I'm trying to do my best as far as writing out equations and stuff so you can kind of see where I'm going. So I actually compiled a few problems from this section that I want you to, that I'm going to actually to start doing. Let me start off with something that just has. So here we're going to kind of get into solving for equations. Let me get a one to do. Yeah, let's just start off with the one I have up here. So I'm going to copy and paste this one into my whiteboard. Okay, so let's see how this is going to work. Now, I developed a little strategy to help students with solving equations, especially when you have an equal sign. This is up to you. You can use whatever method strategy you want, but to kind of get a good picture of what students, how to get things on one side. Because what we need to do is when we say solve for an equation, solve for y, basically what we've been always taught to get the variable on one side of the equal sign and the all the numbers and everything on the other side. So, oh, this is awful. Okay. So what I usually do is I tell students this equal sign, I want you to make a wall. And I don't know if most of you have like a sister or brother back in the day when you had a sister or brother, cousin, niece, cousin, or something that just always got on your nerves. And sometimes when, or even now as adults, sometimes we just want to be by ourselves. We have too many things going on, so all this stuff is going on, but sometimes it's just you need to get into this quiet place and have just a few minutes to yourself because your siblings or your family members are just bothering you. So I kind of picture myself as being one of the variables, and I want to make sure at the end of this problem, I would like for this y to be by itself, and then all the commotion and chaos to be on this side of here. So this is what our ultimate goal we're trying to do. So before we get started with the problem, you always look on both sides of the wall and ask yourself, can we do anything to the problem? Can I do anything over here? Well, because both of these has y's, remember what we talked about collecting like terms. We want to try to make sure we get each side of the wall straight before we start moving over things over to each side of the wall. So here we have 2y plus 2y, which is going to make 4y. And over here, we can't do anything to this 3y plus 5 because they're not like terms. So we're just going to kind of write that down. Now, if you notice, this 4y is supposed to be a highlighter, sorry. And this 3y both have y's. So this is where I want to combine, get ourselves together. So remember, it does not matter if the y can be on this side of the equal sign or this side. That doesn't really matter. But since I'm already kind of have everything stashed on the left side, I want to move this guy, this term, over this equal sign to combine with this y. And in order to do that, you always have to do what is the opposite is what it's doing right now. So look at this problem here. Because this 3y is positive, when I move it over, what is the opposite of positive? It's going to be subtraction. So once I subtract both of these, notice what happens on this side. 3y minus the 3y, they just all cancel out. So then I just drop down the 5, which is left over. And then over here, I say 4 minus this 3, which leaves me with just y. So notice with this problem here, my y's are by myself on this side of the wall, and the 5 is also by itself on this side of the wall. So because this is the case, I am done with the problem, and the answer is going to be y equals to 5. So let's do another example. So for this particular one, we're going to be solving for x. So that means that I need to move the -3 over to this side and the 4 over to this side, because these guys are kind of like I said, as far as my illustration, they're getting on my nerves, and I need to move those people over to this side of the wall so I can be by myself. So I'm gonna go ahead and put up my wall. And a good question that a lot of students sometimes ask is, what do I usually move first? I know I have to move the 4 over, and I know I have to move this -3 over, but what do I need to move first as far as a problem? A good note that you can write down is always move the number or variable, whatever you're talking about, furthest away from what you're solving for. Since I'm solving for x, look at these problems here. Which one is considered to be the furthest away from this x, the -3 or the 4? Well, these are kind of on top of each other, and this is kind of off to the side. So because this is off to the side, I will move that one over first. That's pretty much a good way to get an order as far as what to move first to get your problem correct. So again, we'll do the opposite. This will help also show work as far as knowing that something will cancel out. So this cancels out. So -7, -7 plus 3 will give us a -4. And then I drop this down because I didn't do anything to this particular problem yet. Now, how I'm going to separate these two, and I did the opposite of subtraction over here, but if I look at this one, always call out what it's doing. If you actually say it, then that'll help you know what the opposite is. X divided by 4. So if x is divided by 4, what is the opposite of division? Well, it's going to be multiplication. So put my little dot for multiplication. That way, this one cancels out with this one. And then the only thing left over on this side of the wall is just my x. Remember, that's us. We want to be alone. Over here, -4 times a 4, that gives us a negative 16. Now, one of the beautiful things when you work it, when you're about to start your quiz or when you work your test, is you have actually the ability to check your work to make sure your answer is actually correct before putting in, check answer or submitting your work, before you hit submitting your quiz or whatever. If we're saying that x is equal to negative 16, well, why don't we just plug it in, take about 2 or 3 seconds, plug it back in to see if it actually works. So if I plug this in here, negative 16, this is actually what we did in section 1 when we actually substituted numbers in to make sure they work. Negative 16 divided by 4, if we throw that in our calculator, wouldn't it equal to negative 4? And then if we minus 3, that gives us negative 7. It looks like it checks out to be the answer. So we naturally know we got at least one right on a quiz or a test. So let's do a one that has a little bit more, I would say a little more beef to it. Well, y'all probably don't like fractions, so I guess I have to do that one. Okay, so for this one here, so once again, this K is us, and we need to get all this by, we have to get everything by itself. And let me put on my wall. So we already kind of know this guy has to come over here. This 1/3 needs to come over here, and this 7/10 needs to come over here also. That way K can be by itself at the end of the problem. So for here, again, ask the same question. Which one is the actually the looks like the furthest away from this K? And meaning that on this side of the wall. I'm not worried about the 1/4. But what is the furthest away? So these are side by side. This one is really close. So the 1/3 looks like is going to be the one that's actually going to be the furthest away. So if I take this and add it on both sides, we notice again that this one will cancel. And then we can come to our calculator and do, in parentheses, 1 divided by 4. And you can actually use the alpha feature if you want to make your fractions, number 1, and then 1/3. And that way you don't have to use the parentheses. Well, if you don't have that feature, alpha feature, you want to do it with the parentheses. If you do, you can change it this way. So here we get this, we hit math, enter, enter, and we get 7/12. So over here, we add these two together, we get 7/12. And then down here, I didn't do anything with this 7/10, so I'm just going to drop this down. So again, we're going to ask ourselves, what is this number? I know this is a fraction, but this is still considered to be a number. 7/10 being doing to the k. Because we're side by side, they're being multiplied. So it's because you said multiplication, and I need to take this 7/10 over to this side. What is the opposite of multiplication? Will be division. So I would divide the whole fraction on this side and divide the whole fraction also on this side. That way, when we have the same number, just like if I have 5 divided by 5, that equals to 1. They just, we basically say they both just cancel out to get to 1. because the understood 1 is actually in front of this k. So if I come to the calculator again and divide it by 7 over 10, you can just, since it's already in there, I can just hit divide. 7 divided by 10, and then change it to a fraction. My answer should be 5 over 6. So once again, to check your work, take 5 over 6, multiply it by 7 over 10, minus it by 1/3. We should get 1/4 to be our answer. I think now we're kind of ready to start a problem with a little bit more to it. So for this one here, we're going to take this problem here and we're going to do the same thing. And as far as ask ourselves, what are we going to move first? So let me try to rewrite this one. So looking at this problem here, I want to get x by itself, but I have a lot of stuff going on one side of this equation. So because this is in parentheses, this 2 is the closest to the x. Then the 3 is probably the closest, but the 6 is probably the one that's the furthest away. So this is what actually I'm going to decide to move first over this side is the 6. And because it's being divided, we're going to actually take it in now to do the opposite, which is multiplication. So I'm going to times this side by 6 and times all over here by 6. And if it helps you, put this in parentheses so you'll know you multiply everything by the 6. So that way this one cancels out with this one, and it just leaves me with the 3x plus 2. And then I'm going to distribute this inside to be 12x minus 12. And then now I'm going to distribute this one in next to be 3x plus 6. And it's going to be equal to, again, 12x minus 12. So now we look on both sides of here, we can say that I want to combine like terms. This has a 12 over here, this has a 3 over here. Now you can move the 12 over here, but because this 12 is larger, I don't want to deal with a negative number by moving it over here by subtracting. So this will be a good example to show you that it does not matter if the x is on this side or this side. So I'm going to actually move the 3x on this side. And then I'm going to cancel this side out. And I'm actually going to now move the 12 over to this side. So it's a kind of like a swing action, kind of like once you move one side over, you got to take something else on this side and move it over here. So that way this side over here, they cancel out. So 6 plus 12 gives us 18 equal to, and then 12 minus 3, in this case here, will give us 9. And then this, because they're side by side, we're going to do the opposite. 9 times x, I'm going to actually divide it. And then these cancel out. So on this side over here, I have my x is equal to And then 18 divided by 9 will give us 2. So I hope this actually kind of helped us as far as getting understanding. And this again came from sections 4 through 6.